Okay, so welcome to this tutorial where we're going to look at how we can deploy a machine learning model as a web application using an open source app framework called Streamlit. So I've created a Git repository that you can look at during this walkthrough or afterwards. So last time we looked at this machine learning low-code library called PyCaret for training and exporting our machine learning model. So we will use this library in this notebook as well for predicting heart failure, but we won't go into details of this library here. So cardiovascular diseases are the leading cause of death globally, and approximately 18 million people died from it in 2019. And of these deaths, 85% were due to heart attack and stroke, according to World Health Organization. So the inspiration here is that people with cardiovascular disease or who are at high cardiovascular risk need early detection and management, wherein a machine learning model can be of great help. So imagine that you're working in a research lab and your team has got access to a data set to predict heart failure. As we can see here with 11 features. So as age, gender, chest pain type, resting BP, and so on. So the first thing we want to start is to get an understanding of the data set. So I've just done a minor step there. So just looking at some of the biases that could be in the model. So like the age, we can see that that's between 28 and 77. And we can also see that the data set is imbalanced in form of the gender. So we have 725 males and only 193 females. So then we can continue to look into how on the target task, how many patients we have with heart disease and how many we have that are normal. So you can see that 508 of them have heart disease and 410 of them are normal. So it's balanced in the target task. So then we split the data into training and test, and we do this by 15%, and we get 780 rows for training and 138 rows for testing. So before we continue, it's important to see if the test set is balanced, and we can see that it is. So it has 72 subjects that are normal and 66 that has heart disease. So then we continue with importing the necessary things from the classification container or the module in PyCaret. So last time we used regression, so that's different here. Then we use the setup in PyCaret and define the target task, which is heart disease, and define the k-fold size and so on. And we get more details here. Then we train all the models that are available in PyCaret by using these compare models and get the best models. We don't do any hyperparameter tuning here since it takes time, but we combine some of these models, and when we are happy, we do we analyze the results, and we can see that in the confusion matrix it looks quite well. And this is also shown in the accuracy, with 87.6 in the accuracy. And finally, before putting our model into production, we want to train on all the data we have available. By this, I mean all the data we have available with labels. So we do this by finalize model, and take the final model, and then we export our model. So we get this final model heart failure pickle file. And then the next thing, we want our model to be available for the end user so they can make use of this model. So we will do this with the open source app framework called Streamlit, as I mentioned. So the first thing we start with here in this notebook is to import all the necessary things we need. So, and it's not necessary to import more than what you need. So here you can see that for the PyCurve classification module, we only import load model and predict model, since that's the only thing we need here. So then we can start to make this Streamlit application, and we do this by first defining a Python class. So we call it Streamlit application. Then we define a constructor, so with the init, and you can see that we load our model, this one. And we also define path.csv. So I will come back to why we do this. So the next thing, to make this user interface for this application, we make a method called run. So def run. In there, we first start with making an image. So we put an image into the application in the top. Then we make a selection bar. A user can select if they want to predict for a single patient or batch-wise. So imagine that you put your application into production, and another research lab finds this application very interesting, and they have access to similar type of data, and they want to predict on those data. Then it won't make sense that they have to make prediction on a single image at a time. So instead, they can use their CSV file and just predict on the entire CSV file. So that's why we want to do this. So we will look into how we implement it later in this method. So then we just define the information title, and if it succeeds, success, and so on. So then the first thing, if we want to predict on a single image, then it will be add select box equals online. You have a number of features as defined in the CSV file. So the users will have the option to give the values, and also for the checkbox. And at the end, you want to make these selected values into a data frame. And when they enter predict, you predict with your model. So we do this with our method called predict here, where we take the loaded model and the input data. And you can also see in the next cell that we store the prediction. So the reason why we want to do it is that in the future, when we know the outcome of the patient, we can add this as a column with the target, true label target, and evaluate how our model performs. So, and this could also be used as future training data. So the way we do it here currently is by making CSV file. So if it exists, then we just load it, and then we append to it and store it. Otherwise, we create this CSV file called path.csv. So this works locally, but when we put it into like Heroku, as we will see later, then this won't work. So in your assignment, I would recommend you to see if you can store these data that you're going to use in a database in some way. So yeah, so that's it. Then finally, you get an outcome that is 1 or 0, but that doesn't make sense that makes sense for you that knows this as a researcher, but the end user don't know this information. So instead of returning 1 or 0, we return if the output label is 1, then we say that it's heart disease, otherwise it's normal. And we show this for the users here by SD success. So And if the user selects to do it with the batch, as I mentioned, with like if a research lab or something wants to use your application and see if this is something they can use, then they can upload their file and predict on the entire file. So that's it. That's the class for Streamlit, and that's everything. Then to run this, we have to make a object. So we do that and call the method assay run, right? So we do this, and we have to do this in the terminal. So to do this, we have to make this notebook into a Python file. So we do this by converting this file. So then we will get this file, and we want to make this, rename this to app. So it's already existing, so I will delete this now. So then we have this application, and in there we have to remove the final line that we saw in this notebook here. This one should be removed so you can run it. Okay, so then you have it. Then we can go into the terminal, and you can see that we are in this .158 PyCard deployment folder, notebooks. So here we want to then type Streamlit, run app.py. Then it will give a link. This is locally. So you can see that we get all these features that could be selected, values, if it's a female or male, and so on. And then, yeah, checkboxes here as well. Then you get a predicted output. So here it says heart disease. And you can also do it by batch. So you can go here and select and browse through files and select the CSV file we want to use. So, okay. So that's it, and we can also see that we have the CSV file that has stored the information about the patient. So the next step is to make this application. So this is only available locally, so we want to make it available through a URL. So we can do this with Heroku. So if we go into the third notebook, here's only a description of what we should do. So you need a requirements text file, which contains the names of Python packages required to execute the applications. So we can look at that. So if I go one step back again, here, PyCard deployment, and look at the requirement text, you can see that it requires PyCard and Streamlit. And also with the setup, then you have this setup bash script used for creating necessary environment for our Streamlit app to run on the cloud. So that's defined here. Then you have this proc file, which is a code that provides startup instructions to web server that indicates which file should be executed when the application is triggered. So you can see it here that we want to trigger the bash script and the run.py file. Okay, so here is just some refactoration I've done. So I put our train model that we have here. So this is not necessary. This one is already put out here. And the same with the application, so that's also similar. So this is already in there, so this could be deleted. So now we have all the things we have needed available here. Then we push this up to GitHub. So yeah, that's where we are now. Then we have to go to Heroku. So you have the instructions to what you have to do there. So sign up and create a new app, connect to the GitHub repository and deploy a branch. I already signed up, so then I go to this create a new app and choose the name of the application. So we will just call it .158 heart. Yeah, just call it .100 Then we will select Europe and create the app. Okay. Okay, I have to go in again. So okay, then we have created this app. Then I will connect to GitHub, which I've already done. And the name of the GitHub repo is .158 PyCredit deployment. So I just call this .158 PyCredit to search for all the repositories, and I find this one. And then we deploy our branch. Then it will run for almost 10 minutes, and you have a web application at the end that you can open wherever you want. So that's